Oh, hi there. My name is Frenchie. Welcome back to another amazing video made by, you guessed it, us. Whee! Woo-hoo! Hop! Hop! Wait for me, Rabbit. You know I'm not a good runner. Oh, relax, Byron. You're the best runner I know. Thank you. Oh, hi guys. My name is Lop. Today we are going to review our perfect squares.
Perfect squares? I forgot. What are perfect squares again?
Don't worry if you forgot. We talked about perfect square numbers, in fact, with our algebra review videos. If you want to watch our algebra videos, just go to the math playlist and click on the algebra videos. We learned how to solve the order of operations now that we knew a lot about exponents and raising numbers to certain powers. But did you know that there is an infinite set of square numbers?
There are infinite square numbers?
Yes, as long as you multiply a number by itself, it could be considered a square number. Let me show you this little example that I find pretty handy. This is all 12 square numbers from 1 times 1 to 12 times 12. Now, they are not completely all the square numbers because there are square numbers higher than 144. But we are just going to begin learning about the first 12 because I have a feeling that 12 times 12 should be the maximum square number that most children should know at an early age. So 12 times 12 is the max for many people, especially third graders who are still introducing the multiplication concepts. That's right, you first learn multiplication in third grade. Possibly in second grade because of arrays, but I'm not so sure about second grade. But, anyways, there are infinite square numbers, just like how there are infinitely many numbers. Just as long as you multiply one number by itself, the result will be a square number. For example, let's look at these first 4 square numbers. Now, the first 4 square numbers are pretty easy. In fact, they're pretty much the easiest. So, when third graders are kind of stumped about these kinds of numbers, and 6th graders too, the easiest ones they should start learning about are these ones, 1 to 16. Don't worry, I'll walk you through them, because many kinds of kids still don't know what square numbers are, and they have difficult times finding out the answers to these problems. Okay, so 1 squared. So 1 squared is 1 times 1. And anything times 1 is that number. Well, 1 times 1 is 1. So 1 squared is 1. So we could conclude that 1 is the first square number. This may be weird for me to say, but 0 is not a square number.
What? But 0 times itself equals 0.
Yes, you're totally right, but 0 is not a square number.
Why not?
Well, in order for a number to be a square number, it has to be positive. 0 is not positive or negative. It's actually a special number called a neutral number, which is neither regarded as positive nor negative. So it's not positive or negative at all, because it represents an empty value. So if it's not positive, then it cannot be a square number. Since 0 is not positive, it can't be a square number.
Oh, yeah! But what exactly are positive and negative numbers?
We will discuss those by the end of the 6th grade Volume 2 program in Unit 9, so don't worry. We're just going to focus on our perfect squares, and we're going to do it up to 12 times 12, because I think that 13 times 13 and onwards would be too difficult for you guys. But it doesn't hurt to give it a go. You just need to multiply one number by itself. But today we're just going to review our easy square numbers, like our laid-back kind of numbers, our laid-back kind of mathematical pals, up to 144. Come on, everybody. Let's do this. So, as I mentioned before, 1 squared is 1. That makes sense because 1 squared is 1 times 1. But it's not 1 times 2. Be careful over here. This is a very common mistake that most people make, as we mentioned in our previous video. Do not multiply the base by the exponent. Only multiply the base by how many times the exponent tells you to. So, if the exponent is 2, then the base would be squared, and it would be a square number. So 1 raised to the power of 2 is not 1 times 2, which is 2, by the way, obviously, but rather just 1 times 1, because they are two 1s being multiplied together. And what do you get when there's only one thing in one group? 1, of course. So 1 squared is 1. 2 squared is slightly a little harder, but shouldn't be too hard, because we already know that 2 squared and 1 raised to the power of 1 are the only exponential values in which you have to multiply the base and the exponent. Those are the only ones. And that makes sense, because 1 raised to the power of 1 is simply 1. Because anything raised to the power of 1 is simply that number. We're multiplying it only one time, which is really not multiplying anything at all. So we're just leaving it by itself. 2 times 2 is 4. But if we multiply the base and the exponent, 2 and 2, that also makes 4. So only multiply the base and the exponent of 1 to the power of 1 and 2 to the power of 2. No other exponential values can you ever do that so. So you see, 1 to the power of 1 and 2 to the power of 2 are the only exceptions. They are the only numbers in which you have to multiply the base by the exponent. All other numbers, you have got to do repeated multiplication. Alright, so 2 squared is simply 2 times 2, which is surprisingly also 2 plus 2, which is 4. Because 2 plus 2, there are 2 2's. That makes 4. And if you multiply 2 2's together, that also makes 4. Well, obviously, if we add 2 2's together, that's 2 2's. And 2 times 2, which is 2 2's, make 4. 4 from 2 2's. So 1 and 4 are pretty much the easiest square numbers to recognize, especially because 2 squared is the only square number in which you have to multiply its base by its exponent. Besides that, no other square numbers should you ever do that, because that would not make sense. So 2 squared is the only exception. Only multiply the base by the exponent with 2 squared and 1 raised to the power of 1, because those will give you the correct answers. However, all other numbers, you have to skip that step, especially if it is a different number raised to the power of 2 besides 2, because that leads us to our next square number, which is 3 squared, and 3 squared is 9. We know that because 3 times 3 is 9, but 3 times 2 is not 9. 3 times 2 is 6. We don't multiply the base by the exponent. You could do it with 2 squared and 1 raised to the power of 1. But 3 to the power of 2, no way. You have to multiply 3 2 times, which make 9. So they're pretty much the easiest square numbers to know. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. Then 4 squared is 4 times 4, which is 16. So 1, 4, 9, and 16 are the first 4 square numbers, and they're the easiest to recognize. Now, if we kick it up a notch, we are getting into the slightly harder square numbers. 5 squared to 8 squared. These are medium difficulty square numbers, but 5 squared should be the easiest to remember, because, as we just saw by this square drawing, a 5 meter by 5 meter square has an area of 25 square meters. And we know that because if we split the square into 25 parts, and count its length and width, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, both of them are 5, which means that both of these must also be 5, because a square must have all 4 sides equal, not just 2. So, yeah, that's how we could prove that 25 is a square number. So, 5 squared is 5 times 5, which is 25. 6 squared may be a little tricky, but here's a helpful hint. It must end in a 6. So, 6 squared must end in a 6, and it must be greater than 25. So, 6 squared is simply 6 times 6, which is 36. Do you want to know why? Because if we multiply 6 and 5 together, that gets us 30. And if we multiply 6 by 6, that is simply 30 plus 6, which is 36. So hey, 5 squared is 5 times 5, which is 25. And 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. And 8 squared is 8 times 8, which is 64. So 25, 36, 49, and 64 are the next 4 square numbers, and they're slightly harder to learn, but they're only medium difficulty when compared to one of the hardest square numbers to learn, 9 squared to 12 squared. I'm going to tell you, 12 squared is the hardest square number for 3rd graders to memorize and recognize because of its large base. But 3rd graders should not learn about exponents just yet. They should only know about the perfect squares. So, yeah. So, 1 squared to 8 squared, 1, 4, 9, 16, 25, 36, 49, 64, that's not too bad. But when we compare it to 9 squared up to 12 squared, these start to get a piece of cake. They're really easy. They're a piece of cake. And this one is kind of tricky. This is kind of hard. These are one of the 4 hardest square numbers to recognize and memorize. But keep in mind that children should have no problem mastering 9 squared and 10 squared. So don't worry if your children just get a head start with those 2, because those 2 are easy. But 11 squared and 12 squared may require more work. So I'll review it again, 9 squared and 10 squared, and 11 squared and 12 squared, so that we could go through all of our square numbers as we promised. So 9 squared is simply 9 times 9, which is 81. Now, I know that 9 times 10 is 90, but when we multiply 9 and 9 together, that is simply 90 minus 9. Because when you multiply 9 by a number, you add 9 every time. So 9 times 9 is 9 less than 9 times 10, which is 90. So 90 minus 9 is 81. So 9 squared is simply 9 times 9, which is 81. And 10 squared may seem a little confusing, but it should really be very easy, because raising 10 to the power of a number is simply just adding the amount of zeros in front of it. In other words, if 10 is raised to the power of a certain exponent, then we have to add that many zeros in front of 1. So, in this case, 10 is raised to the power of 2. So we put 2 zeros in front of 1, which make 100. So, yes. Plus, if we count our 10s, 10, 20, 30, 40, 50. That was 5 times. 60, 70, 80, 90, 100. That was all 10 times. And we were counting by 10s. So counting up to 100, as you learned in kindergarten, is simply just counting up to 10 times. Except you don't exactly count up to 10 because you count up to 20 and then 30 and then 40 and then 50, which could be confusing for many people to understand, especially kindergarteners. But this should make sense to most people because 10 squared is simply just 10 times 10, which is 2 zeros added together, which makes 100. So I'll review it again. 9 squared is simply 9 times 9, which is 81. 10 squared is simply 10 times 10, which is 100. Now, 11 squared and 12 squared, you may need a little more work. So, luckily, we know a clever way to multiply a number by itself. Really? Yes! You learned how to do 2-digit multiplication in 5th grade. And we're in 6th grade right now, so this should be no big deal. Okay, this is what you're going to do. 11 squared is 11 times 11. We know that, so let's write 11 times 11 down. This is 11, obviously, and then this is 11. That is how the perfect square equation should be written out as 11 times itself, or 11 times 11. Now, let's do the work. 11 times 11. Well, 1 times 1 is 1. Duh. Then, you have to do it over here. 1 times 1 is 1. Then we add a 0 under it, because 11 times 11 is not 11. Hello, so we have to add a 0 under it. Now, do this column. 1 times 1 is 1. Sorry, not a column, just this part. And then this part. 1 times 1, which is 1. That simplifies to 11 plus 110. So we simply just add the numbers together to get our perfect square answer. 1 plus 0 is 1. 1 plus 1 is 2. And nothing plus 1 is 1. Looks like we figured out what 11 times 11 is. That's right. It is 121. And how do we know that? Because, we just did 11 times 11. And we got 121 as our answer. But that is only one square number mastered. Now we have to master the hardest square number, 12 squared. How can we prove that 12 squared is 144? Well, let's see. Let's write 12 times 12 in vertical form. There we go. 2 times 2 is 4. 1 times 2 is 2. That's 24, but then we put a 0 under it. 1 times 2 is 2. 1 times 1 is 1. Now, if we add 24 and 120 together, 4 plus 0 is 4. 2 plus 2 is 4. And nothing plus 1 is 4. I mean, 1, sorry. I get confused with 4s. Nothing plus 4 equals 4. Nothing plus 1 equals 1. Obviously, excuse me. So, we know now what 12 squared is too. It's 144. And how do we know that? Because we did our multiplication problems correctly. You could also check to see if 10 squared is 100 by doing 10 times 10 this way. But thanks to our clever method, we don't need to use these. But just in case you want to know how to do it the long way, an awful way, and surprisingly applicable way, if there's no other option, then simply do this. 0 times 0, that's 0, right? And then 0 times 1, anything times 0 is 0, so that's 0. But then we add another 0 under it. Get it? 10 times 10 is not 0. Duh. 1 times 0, 0. 1 times 1, 1. 0 plus 100. You guys, this is pretty obvious here. This is how you find 10 squared the long way. Simply just do 0 plus 100, and it gives you 100. It gives you the answer right there. So, yeah, it literally gives you the answer. And 1-digit multiplication should not be too bad. But just in case you want to know, 9 times 9. Well, we know that 9 times 10 is 90. But 9 times 9 is 9 less than 90. So 90 minus 9 equals 81. So, yep, it's simply just 81. That's the long way to do one-digit multiplication, which is really actually the short way. Because it's not a two-digit multiplication where you have to add. So, yeah, pretty easy there. Let me just close my marker, because it won't close on its own. Come on. Okay, there we go. That was a lot of numbers. But hey, we made it. Now we know how to find out square numbers. Just multiply a number by itself, or use one of our hacks like we did. But hopefully, these square numbers up to 144, and as small as 1, could be very good to review. Keep in mind that, again, 0 is not a square number, because remember, 0 is not positive. And if we try to draw a square with 0 things on it, that's nothing. We can't represent it because it's empty. So 0 cannot be a square number, although it technically meets the naive definition of a square number. But it's not positive, so 0 doesn't count as a square number. This means that it doesn't count as a cubic number either, because 0 times 0 is 0, and that times 0 is 0. So, yeah. Cubic numbers are a little trickier, because you would have to multiply the same number 3 times instead of 2 times. But I will tell you the cubic numbers. Don't worry. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. I know, very cool. 4 cubed is 64. Wait a minute. But 8 squared is 64. 64 must be a square number and a cubic number. It's the only one of those. It's the only such number that could be a square number and a cubic number too. 64. A very special number. Anyways, 5 cubed is 5 times 5, which is 25. Times 5 is 125. So cubic numbers up to 125. Because we simply just know our square numbers by now. So, parents, if you want to teach square and cubic numbers to young children, not too young, like 3rd graders, you should start off with the easiest ones, like 1 to 16. Those, they should know. Only if they do their multiplication pretty well. And if they practice their multiplication problems. Remember, 3rd grade is when we introduce multiplication. Then, once the children start to master 1 to 16, you could kick it up a notch and turn it harder. 5 squared to 8 squared, which is 25, 36, 49, and 64. And then, when they get the hang of that, they will unfortunately have to start gaining their understanding of the much harder square numbers because of their much larger value, 81, 100, 121, and 144. But thankfully, based on our 5th grade 2-digit multiplication prior understanding, we know how to find square numbers. Simply multiply a number by itself in vertical form, and you get the answer. So, yeah, that's it from us, kids. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144 are the first 12 square numbers. And 1, 8, 27, 64, and 125 are the first 5 cubic numbers. Want me to prove it? 1 times 1 is 1 times 1 is 1. So 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 8. 2 times 2 is 4 times 2 is 8. So 1 cubed is 1, 2 cubed is 8. Then 3 cubed is 3 times 3 times 3, which is 9 times 3, because 3 times 3 is 9 times 3 is 27. So 3 cubed is 27. Then 4 cubed is 4 times 4 times 4, which is 16 times 4, because 4 times 4 is 16. And if we multiply 16 and 4 together, we get 64. And finally, 5 cubed is 125, because 5 times 5 is 25, and 25 times 5 is 125. So we are working with cubic numbers as high as 125. And we are working with square numbers as high as 144. So the cubic numbers are more difficult because we need to multiply such numbers 3 times. That's surprisingly also why a cube has 3 dimensions, length, width, and height, because if you're cubing a number, you multiply it 3 times by its length, width, and height. And in this case, the volume is 125 cubic centimeters, because 5 times 5 times 5 is 125. So that's it, kids. 1, 8, 27, 64, 125. Hang on, I have to memorize those cubic numbers and make sure I got them right. Hang on. 1 times 1 times 1 times 1. Wait, no, that's 4 ones. I'm sorry, way too far. Okay, I can do this. 1 times 1 times 1 is 1. There we go. 2 times 2 is 4 times 2 is 8. There we go. 1, 8. Then 3 times 3 is 9 times 3 is 27. 1, 8, 27. Then 4 times 4 is 16 times 4 is 64. 1, 8, 27, 64, 125. Yes. Now I got it. 5 times 5 is 25 times 5 is 125. If you just want to know. But that's it from us today. So, yep, parents, this is a good stopping point, because I think that for higher square numbers and higher cubic numbers, your child may need to know a whole lot more. But don't worry, we are simply just doing this for review. 13 times 13 and higher, we're not going to cover in this math expressions program. So, yeah, these are the square numbers up to 144. I hope you enjoyed this video. So, parents, if you want to know what the highest square number that third graders should learn, it's 144, 12 times 12. So, after children master 12 times 12, then just stop there, because I feel like that 13 times 13 and beyond are way too hard for a child to process. That's more for middle schoolers and junior high students to figure out. By the way, if you're interested, 13 times 13 is 169, but you don't need to know that. You could give that a rest. So, yeah, just welcoming you with the square numbers up to 144 and the cubic numbers up to 125. See you guys later. Bye-bye. Stay curious.
Bye, everybody!